Okay, as we begin lesson 2.1, integer exponents, the essential question asks, how can you develop and use the properties of integer exponents? What you're going to do here is you're going to use patterns to figure out some of the rules. I'm going to fill these patterns in for you before the page comes up. They're in your book. This is beginning on page 33. And the rules aren't that difficult. And on any test, quiz, or otherwise, even on the PSSA test, you will have these rules in front of you, so there's no need to memorize them. So don't worry about that. Let's move on. Okay, so this is still on page 33, and you have these patterns here. 5 to the 4th is 625. That's 5 times 5 times 5 times 5. 5 to the 3rd is 125. 5 squared, 5 times 5 is 25. So as you're going down this pattern of 5, as you go down and take 1 away from the exponent, you're actually dividing every step by 5. So 4, 3, 2, 1, etc. You're dividing by 5. 625 divided by 5 is 125. 125 divided by 5 is 25. 25 divided by 5 is 5. And then again, you go down one step. 1 minus 1 is 0. 5 divided by 5 is 1. And then you cross over to the negative exponent. And you're still going to divide 1 by 5. Dividing 1 by 5 is 1/5. And then as this one, as you were going down by 1, you were dividing. When you cross over, you're still going down by 1, but once you're in the negatives, you start multiplying the denominator by 5. And that pattern continues all the way through here. For the 3 to the 4th is 81. 3 to the 3rd is 27. 3 squared is 9. 3 to the 1st is 3. Again, you're dividing by 3 each time. You're subtracting by 1 on the exponents. So 1 take away 1 is 0. Divide 3 by 3, you get 1. The more important part of this is notice that every time you have a 0 exponent, no matter what your base is, you're going to have a 1 as your answer. So anytime you have a 0 exponent, regardless of the base, the answer is always 1. Again, whenever you do these problems, 3 to the negative 1, what you actually have to do here is write it as 1/3. This one's written as 1/3 squared. Of course, 3 squared gives you 9. I'm going to pause, fill these out, and then come right back. Okay, ladies and gentlemen, so this is now on page 34, and they're going to take exploring properties of integer exponents, complete the following equations. So here you have a base of 3. You have a 1, 2, 3, 4, 5 times. So this is going to be 3 to the 5th power. This time they have that same 3, the same base, but they group this as 4 3's together and then just a single 3. So you have 4 3's in this first group, just a single 3, and you add the exponents. 4 plus 1 is 5 because you do indeed have 5 threes here. The next one down is we have the same 5 threes, but they're grouped in 3 and 2. So 3 to the third power is your group of 3. 3 squared is your group of 2. But we still have 1, 2, 3, 4, 5. So it's 3 to the fifth power is what it equals. So you can see that everything here is 3 to the fifth. So they're asking you for what power that you see. I'm sorry, what pattern that you see. So when you multiply the same base, what kind of pattern are you seeing? That's what they want you to answer down there. So think about it and I'll be right back. Okay, so what pattern do you see when multiplying two powers with the same base? You must have the same base for this to work. The result has the same base, so the 3 has the same base, they're all 3's, with an exponent equal to the sum, that means you added, the sum of the exponents of the powers. So let's use this to solve the problem. So 5 squared times 5 to the fifth. We have the same base. So we're allowed to do what with the exponents? So if you have the same base, what do you do with the exponents? You add them together. So 2 plus 5 gives you 7. So the answer would be 5 to the 7th power. We add the exponents together and keep the base of 5. Okay, this make a conjecture. This is actually found on page 35, but I put it here because it went with this page. In fact, I'm going to move it up just a little bit because it goes with this page. So if you have the same base, in this case they're using an A, and you have an exponent of m and an exponent of n, what do you do with the exponents again? How did we get that 7? That's right, we added them. So this is going to be the rule here. This rule is going to say you're going to take the base, keep it the same, and then you're going to add m plus n. Oh, that's ugly. I have to get rid of that. Sorry. You're going to have m plus n. That's the rule. The rule is you're going to add exponents. And all these that we're getting here, that's terrible. All these rules that we're getting, you will not have to memorize. They will always be given to you. Okay, so we're still on page 34 with our conjecture from page 35. Complete the following equation. So you have 4 to the fifth power, fractions are fancy division, divided by 4 to the third power. So what they're showing you here is they wrote all 5 of the 4's out in the numerator, and they expanded the 4's in their denominator. So this is expanded form. It's stretched out. Now, if you take these and divide them, because remember, fractions are fancy division. 4 divided by 4 is 1. They cancel. 4 divided by 4 is 1. They cancel. 4 divided by 4 is 1. They cancel. And all you have remaining are these two 4's in your numerator. So those two 4's are written down. Remember, each one of them, if you can't see the exponent, yuck. If you can't see the exponent, it's actually a 1. So if you have 4 to the first times 4 to the first, you actually have 4 squared. So the question is, when you see division, what are you doing with the exponents? How can we go from a 5 and a 3 exponent to a 2? What operation do we use with a 5 and a 3 to get a 2? That's right, subtraction. So hang on while I fill out this next one. Okay, so what pattern do you see when dividing the two powers with the same base? The result has the same base, so the base was 4, or my answer has a 4 base still, and the exponent is equal to the difference. Difference means subtract. The difference of the exponent in the numerator, well, the exponent in the numerator was 5, and the exponent in the denominator, and that exponent was a 3. So the difference, subtract 5, take away 3, gives you 2. So using this pattern, let's solve this problem. So we have a 6 base, a 6 base. We have 8 in the numerator, 3 in your denominator. So what do you do with these two exponents to find the answer exponent? Remember, you kept the base. So what do we do here with the 8 and 3? That's right, we subtract. So 8 minus 3 gives you 5. So 6 to the 8th divided by 6 to the 3rd is 6 to the 5th. And now for your general rule. Again, the general rule does come from page 35, but since it pertains to this problem, I kind of brought it over. So this is going to be, you keep the base, and you're going to take those exponents and subtract them. So you subtract exponents whenever you divide. Okay, so the last one, again, found on page 34 with your conjecture on page 35. We're going to have a single base, but two exponents. A single base and two exponents. Before we had a base with each side part of the problem. Now we have a single base with two exponents. This is 5 to the 3rd power raised to the 2nd power. Now notice how they put 5 to the 3rd power. 1, 2, 3. So they took what's inside the parentheses and they wrote it out. They expanded it. But the exponent in this case is going to be the 2 because you haven't used the 2 yet. You only used the 3 exponent when you expanded. Now this 2 is telling you that you need 2 groups of these 3's. So here's one group, here's a second group. So how many 5's do you have altogether? Count them up. You have 6 5's. So looking back at your exponents, you have 2 exponents, 1 base. How can you use a 3 and a 2 to get to a 6? You think about that, and I'm going to fill this in. Okay, so the result has the same base. So here was a 5 base. We still have a 5 base. With an exponent equal to the product, that means we multiply the exponents. 3 times 2 gives me 6. So we multiply the exponents. So keeping that in mind, use your pattern to complete this equation. 7 to the 2nd power raised to the 4th power. So what would you do with these two exponents? You would find the product. You would multiply. So 2 times 4 would give you 8. Okay, again, we have this conjecture from page 35. And what you want to say here is your base is going to repeat, but you'll end up multiplying the exponents. Again, these conjectures, these rules that you're going to have, do not need to memorize them. Okay, so I've made my way to page 35. This is example 1 with simplifying each expression. There are 2 of them. In your textbook, this is already done, which I don't like. I'd rather do this together. Simplify within parentheses. So it looks like we have to simplify this, but using the order of operation. So parentheses come first. So let's do our parentheses. 5 take away 2 is 3, and that's still to the 5th power. We have 3 to the negative 8 plus 5 plus 2 is 7, and that power is 0. Okay, use properties of exponents. So the properties of exponents tell me that I'm going to take this 3 to the 5th, and I'm going to leave it for the moment. I'm going to leave 3 to the negative 8 alone. Plus, I have 7 to the 0 power. Well, 7 to the 0 power is 1. So 7 to the 0 power is 1. And they want me to simplify. So I have the same base here, So if I have the same base and I'm multiplying, the rule says I have to I have to add my exponents. So if I'm multiplying, I'm adding my exponents. So 5 plus -8 is 3 to the -3 power. I'm still adding that 1. 3 to the -3 power is 1 over 3 to the 3rd plus 1. So on this one, if I have a negative exponent, I write it as a reciprocal, like this goes to the denominator. So the 3 stays the same, the base stays, and because I moved it to the denominator, this negative goes away and I have a 3. So let's evaluate this. What's 3 to the 3rd power? Well, 3 to the 3rd power is 3 times 3 times 3. That's 1 over 27 plus 1. I better go over here. I'm running out of space. And then I'm going to add 1 to 1/27. That's 1 and 1/27. And that would be, ladies and gentlemen, the final answer. Okay. Okay, so here's problem B, same page. And you see we have a division problem. We have 3 plus 1 raised to the 2nd power, and that whole thing raised to the 3rd power. 7 take away 3, and that is squared, raised to the 2nd power. So let's take care of our numerator. We're still going to have our brackets. 3 plus 1 is 4. We're going to have 4 squared, and that's to the 3rd power. And on my denominator, I'm going to have 4 squared. 7 minus 3 is 4, so 4 is squared. Okay, the next step is we're going to take these properties. We have a single base, 2 powers. So when you have a single base and 2 powers, you multiply, you find the product. 2 times 3 is 6. So this is going to be 4 to the 6th power, and that's still being divided by 4 squared. Now, according to my rules, when I have the same base and I have a division problem, I subtract the exponents. So 6 take away 2 would give me 4, so that's 4 to the 4th power. And if I simplify that further, that's 4 times 4 times 4 times 4, which equals 256. Good job. So here we are on page 35 still at the very, very bottom. There are 2 your turn problems. So you want to simplify these using the rules. Come on back after you try them and we'll look at your solutions. Okay, so these require some space. So what I did here is 6 take away 1, working my innermost parentheses. 6 take away 1 was 5, and that's still squared, and it has the squared on the outside. 3 plus 2 is 5, and that's going to be cubed. Then I want to simplify my numerator some more because I have 2 powers. So 2 times 2 is 4. That's 5 to the 4th. And I have 5 to the 3rd beneath it. So whenever I have division, I subtract the exponents. So 4 take away 3 is 1. So there's 5. If you don't see an exponent, it's automatically a 1. Okay, 2 to the 6th power, that comes from 2 times 3. When I have 2 powers in one base, I multiply. So 2 to the 6th, 10 take away 6 is 4, and that power's 3. And then 4 to the -5th power, I just kept it the way it was. Then I have these bases the same. So if I'm multiplying, I add the exponents. 3 plus -5 is -2. And now I evaluate. 2 to the 6th power is 64. That's 2 times 2 times 2 times 2 times 2 times 2. This 4 has a negative exponent. This has to be written as a denominator. And now it's squared, not -2, but a +2. Now, 4 squared is 16, 1/16. 64, take away 1/16. will give you 63 and 15/16. Yes, you should be able to work with fractions. So go back to your Schoology page and see what you have for your assignment. Thanks.